We're back live from Age Management Medical Group, AMMG, and Boston BioLife from Doral, Florida. It is a beautiful day outside. It's a little chilly in here. As you see, everyone's running between their blankets and their jackets, but it is fantastic because as we age, it's definitely better to be cold than hot, is all I can tell you. And Donna White is perfect example of how we all need to be educated on our bioidentical hormone replacement therapy academy. So for more information as we bring guests forward, you can always go back to this stream, you can go back to our previous streams and get information, or contact Joe Krieger at Boston BioLife and he will get you all the contact information that you need as well for any information on the guests that you've seen here and any of their companies. So now we have Ian White with us, founder of Neobiosis. And Joe is here, and Joe, I'm going to let you do the intro on this one.
Okay, so I've been working with Dr. White for the last, 4 or 5 years now, and he's the preeminent scientist in exosome therapies, exosome diagnostics and therapeutics, and looking at small extracellular vesicles and their use in medicine and research. And Ian's been in the field looking at this for, 20 some odd years?
Over 20 years.
Over 20 years. He's a published scientist, and he's really someone that is he's a steward in the industry, and that he cares about the quality of the research. He, like myself, are always willing to work with anyone because we all go together. Like some people say, we'll all hang separately, right? Anybody that doesn't understand how the systems go together or how different groups work together really is missing the point, because as science advances, and you'll see a lot of criticism of these new and emerging therapies. You'll see people criticize stem cell research, or you're killing babies, or, this is hormones cause cancer, and really there's a lot of confusion. So people like Ian and his company, what they do is they provide the scientific evidence, they provide research tools for healthcare providers and other manufacturers, and he's always willing to defend the industry. And I think he's a great champion for this group, because this technology fits into this body of scientists and medical professionals, but it also is the future of the way we will treat diseases and how we will fabricate cell-specific, like Robert Brooks talked about,
Right.
His targeted immunotherapies and looking at biomarkers, exosome-based biomarkers for cancer detection. Ian is another scientist working in the similar field, but looking at different areas, so I'll let him tell you some of the areas he's working on now, but he's a great asset to the field, and we're glad to have him as part of what we do.
Welcome, Dr. White.
As part of what you do.
What does Neobiosis, what does your company work with?
So we are focused on understanding how the body naturally repairs itself. As scientists, we're very interested in learning from nature. We've been evolving as a species for over 7 million years, and we've done very, very well. I just, I'm unshaven.
We're still here.
I'm in these clothes. I just came into the conference. I'm speaking in a couple of days, but I just flew in just now. And as I was flying in, I'm looking over the country, and I realized that the human species has been very, very successful. And we've been successful because our biology allows us to interact with the environment very well, and it allows us to heal and respond to challenges, diseases, as well as injuries that we might be exposed to. And we've done very, very well with the technology that has evolved with us over those 7 million years. So at Neobiosis, our goal is just to listen to nature. We're not smart enough to reinvent the wheel at this stage. And so what we do is we look at nature. How does nature deal with injuries, disease? And then we try to develop technologies based on those observations. So for example, I'm very interested in anti-aging, which is why I'm presenting at this conference. And what we realize is that there are many species that have decided over the course of evolution to uncouple biological aging from chronological aging. And so some species just don't age like we age. And what we're really interested in is understanding how they do that.
Okay, what species don't age biologically and chronologically?
So there are some species that slow aging and some species that actually stop aging. So if we look at the Greenland shark, those species can live for over 400 years. If we look at tortoises, just simple tortoises, those large Galapagos tortoises, those can live over 200, 300 years. If we look at jellyfish that are in the ocean right now, Teratopsis dohrnii is what's called the immortal jellyfish, and it's thought to live over 5,000 years, and the only way that it actually dies is through predation or disease. It doesn't age.
Wow.
And so what they do is they use technologies that have evolved over millennia to enable their cells to age and then de-differentiate. And we're starting to understand that technology because in 2012, of course, Shinya Yakanama won the Nobel Prize for iPS cells. And it's using a similar type of technology, looking at 4 growth factors that you can provide to old cells that then de-differentiates them back to an embryonic fate. And in fact, just this week, we saw a publication out of Cambridge looking at skin cells in a 53-year-old woman that they were able to de-age to an age of 23. So those technologies do exist.
I'm in.
Those technologies do exist, but it's all by listening to nature. So the way that we differentiate ourselves at Neobiosis compared to other companies is that we're not trying to find a novel peptide, a novel chemical. We're looking at nature to see how nature does it, and then try to see if we can tease out that information and use it for humans.
So you're here presenting the science of it and how we can put this forward into products or anti-aging skincare or peptides for that matter to see what you can pull out that we can really put into our mammals and our lifestyle.
Yeah, so I'm here to present the science based on the technologies that we're developing in the company. But really, my goal is to be very transparent, like Joe said, bring this industry together and give people the motivation to move forward, because traditionally anti-aging has been a little controversial. You know, people think that it's all about, you know, creams that don't really work and over-promising and under-delivering. But what we're finding right now is that we're on an exponential growth curve of knowledge when it comes to anti-aging technologies. And we're very, very close to finding those key factors that actually will de-age not only cells, but whole individuals. A person could theoretically, biologically de-age. So you're not going to become a baby again, but you may be able to you may have the health benefits of a 30-year-old when you're a 60-year-old, which of course is the most important thing.
Sure.
We're not trying to make immortal individuals. What we're trying to do is improve the health span so that when you are 60 years old, you're healing like you were when you were 30 or even before.
And Joe, how do you see this going into the whole community?
Well, I think it's interesting because one of the things Ian works with is the perinatal space. And in perinatal biologics, these are products that derive from placentas, birth products. You know, because they come from infants, they have so much potential, pluripotent, and they've often been misunderstood. And so I think that as people start to understand what's possible, and what Ian does is he kind of paints the big picture. So you can look at all these individual systems, nutrition and supplements and mechanical devices and different therapies, even things like genetic testing and things, but puts them into the what's possible range. So, you know, we're never going to stop aging. Every day you get up, another day you live, right? And every year that goes by. So, but you might be 75 and behave like a 30-year-old. And I think that's the goal. So we all want to live longer. And you've heard the root cause. You've heard about inflammation. All of these are symptom-based reactions to a body responding epigenetically to its environment. Yeah. We live in a hostile environment. We weren't designed biologically to have radio waves and brush our teeth with fluoride or take shampoo or mouthwash or chemistry or drugs or all the things we take, alcohol. So all these things have an effect, and you know, and I find it amazing that we've adapted so well, because a lot of it has only happened in the last 100 years. Yeah.
Well, what's amazing actually is that everybody talks about how our lifespan is increasing, but our lifespan has always been long. We just lost a lot of our lifespan because of diseases during the dark ages, all those periods where diseases were out of control. And now what we're doing with technology, because the human species has expanded so much, we're having to use technology to keep us alive. So our lifespan is not expanding, but our health span is improving. So we still live up to 120 years. You know, in the history of humanity, there's only one recorded individual who's lived past 120 years.
It was 122, right?
It was a female from France, the only person in recorded history. But the difference of the difference where we're trying to make is that we're trying to increase the health span. So we're not trying to necessarily make everybody live to 150, but what we're trying to do is anybody who lives to 100 is going to live to 100 healthfully.
Right.
That's the key, right? Is you want to be. You don't want to live and have a horrible quality of life, because what are you living for?
Usually, the earlier you die, the worse of the quality of life you have. So, like if you live to 80, you were probably healthy well into your 70s or even 90. You know, but if you die when you're 70, you were probably sick when you're 50 or 55, because all those things express earlier. And I just think it's a question of, you know, he's doing the research, the science, he's putting the tools together, providing the information that people need so that they can understand this. So if you're going to be doing hormone replacement therapy or any of the things that are on this floor, you understand how the system works. And I think, Ian is again a great advocate for the field, but he also provides research tools for companies developing products, people looking at new ways to peel the onion really, and find new therapies and new ideas to help us.
And what I also like to do though is work with Boston BioLife. And whenever I present to you guys, I always present Regeneration 101.
Yeah.
That's like my thing, is that presenting to physicians the basics of regenerative medicine. What is homeostasis? How do bodies stay healthy? And then what is regenerative medicine? How do bodies repair themselves, so that physicians can look at products that are out there right now, technologies, whether it's peptides, hormones, whether it's IV therapy or regenerative medicines, and they can use those toolkits to then treat their patients as an individual, an N of one. So if I can educate them on how the body typically maintains itself and then how it responds to injuries, if they understand those fundamentals that they're not taught in medical school, then they can take all those tools and apply them to each individual patient. And I think that's what's key, is that individualized, personalized medicine.
That's right. And the average physician, is in their mid-50s, and they haven't been in medical school in 30 years.
And it's changed.
It's changed dramatically.
It would be so fascinating. I'm sure there's been a study of what medical school was like 30 years ago, what it was like 50 years ago,
so
what their training is now.
I had a physician do a presentation on the integration of regenerative medicine in traditional medical school. There was only 4 5 years ago. 4.
Yeah.
Duke University, University of Miami, Wake Forest, and one other.
That's it.
That taught regenerative medicine.
That had a program for regenerative medicine, no others.
The other problem with these therapies is you get, just like physicians work in specific areas, orthopedic or neuro or urology, et cetera, so do researchers. So you may be doing cardiac research, and over here's the Regenerative Medicine Center, right? So if we're going to figure out, can we regrow cardiomyocytes, the regenerative medicine guy may have an idea, the cardiac guy has a need, but very rarely do they work together. That's how the neobiosis study happened at Harvard, where they glued the old rat and the young rat together, and they transferred their blood.
Heterochronic parabiosis.
It's one of his favorite words.
Yeah. So the way that we work is that you have all these diseases of aging, and everything that you see at the hospital is typically a disease of aging. If you're injuring yourself and you're not healing, it's because you're aging. If you have neurodegenerative disease, if you have autoimmune disease, there's arthritis, all these diseases are symptoms of aging. And so there are a lot of scientists, very, very talented scientists, working on each of those verticals. But what I'm trying to do is, instead of working on those tributaries, I'm working on the river that feeds those tributaries. So I'm trying to understand the mechanisms of aging, because if you can solve the problem of aging, you can solve all of the diseases that are multi-trillion-dollar burden on our society right now. If you could just find the root cause, and I believe we're very, very close to understanding that, and that's going to be the subject of my book, is how do we understand what aging is and how do we reverse it? And I believe we're very, very close. I believe, in fact, that we have the first 150-year-old and the first 200-year-old individual alive today, and I believe that in our lifetime we're going to see advances that are going to completely revolutionize medicine from the perspective of anti-aging. The next big breakthroughs are not going to come from various aspects of medicine. They're going to come from advancements in anti-aging.
Fascinating. Then it's just going to trickle down to every specialty.
It has to, because every specialty is dependent upon how the body responds to the aging.
But think about the people you've interviewed. You had an endocrinologist, you had an internal medicine doctor, right? So you are finding these doctors that they're sick of looking at the problems that are presented to their doorstep, and they're figuring out, why does this guy have vascular disease? Why does this guy have neurological problems? Why does this guy have a urological disorder? And it's all the same thing, right? And it's the anti-aging doctor or the functional medicine doctor that understood, but no one ever listened to them. So what we try to do, when you see that little multiple circle thing that I put together, is bring everyone together. And that's what you learn by coming to us. But see, people like Ian, where he doesn't have a choice. He's programmed to do this work. He didn't get up and say, I think I might want to try.
This is your passion.
It's what he does. Yeah. It's who he is. And what's so important about that is when other people see problems, you see the light bulbs going off, the eureka moments, and they'll be here. They're like, oh my God, that's why that patient that I treated with this also had that. And like I said, the skin is a good indicator because you can see inflammation. Arthritis is a good indicator. People with low sexual drive,
and then you
people
see
with
blood
hair
flow, and you see diabetes, and you see neuropathy, and all of that.
All of those
and reduced blood flow and
symptoms
inflammation
of the major issue, which is gut health, inflammatory disease, vascular issues,
Amazing.
and all of it translates to disease.
This is so exciting, and once it all gets laid out and brings forward to all of you, maybe Joe will put something together on your site for people to really understand the science.
I'm trying to go in two directions. I've got healthcare providers and technology providers. Now I got to get into the hardcore science. That's why I hang out with people like Ian, and I want to go patient-centered because I want the patient to know the power's in their hands. They should be their own care plan. Remember, the patient becomes a doctor, the doctor becomes a scientist. The whole train moves forward. We are capable of understanding our own biology, our own physiology, our own pathophysiology, and we outsource our most precious resource to a stranger who knows nothing about us, and we pay to do it. $1,500 a month for a family. Go to the primary care there. He measures your blood. He'll whack you on the knee. Oh, good reflexes, and then he leaves. He's looking at his laptop.
So one of the things we're trying to do right now is empower the patient, and a way that we've done that is we've just launched the American College of Regenerative Medicine. Yep. And although that's an academic college, we actually encourage the attendance and the participation of general public. So everybody from physicians, scientists, just to advocates, lawmakers, anybody that's interested can come to the American College of Regenerative Medicine, learn what we're doing in regenerative medicine, in the field of regenerative medicine, contribute, and then become advocates so that we can make change in the United States to advocate for this advancement in medicine, which is coming. We just need to work together to demonstrate that it's not only safe, but it's effective, and it's the future of medicine.
Scientist, healthcare provider, patient. That's the three-legged stool that makes it work.
Scientist, provider, patient. You all work together. Empower yourselves. Be your advocate. Get the information. There is so much information out there, and I love what you're doing, putting this forward for the patients.
Sandy's from Miami.
Are you?
Right down the road here.
You sound like it. I would have definitely figured.
That's my Miami accent.
You're definitely that Miami accent.
Miami.
You gave it away.
He has a British accent, and he has a Vermont
and his tax is Alachua, so now I'm thoroughly confused. We're going to be right back. Thank you to Dr. Ian White and Joe Krieger from Boston BioLife. We'll be right back.